with this standard, we have to protect the employee from exposure. Okay, that's what we're talking about. So if we're talking about silica in a respirable form, we have to speak about breathing. Okay, we're going to breathe something in. So an average person breathes 12 times per minute. Okay. If they breathe 12 times per minute, how much air do they breathe in a common day? Okay, or in an 8-hour day or shift, because we're dealing with employees. So normally in, say, when we're talking about per minute, okay, 35 liters per minute, 60 minutes. Okay, of course, as safety professionals, we should know our math, right? And 2,100 liters per hour over a course of 8 hours, an average individual will breathe at least 16,800 liters per 8-hour shift. That's how they breathe in, breathe out. So you can just imagine how much exposure they can get throughout a day if you're dealing with a respirable. Okay. So as we breathe in, breathe out, primarily we should be breathing through the nose, right, and then mouth. Okay, and then so we have the respiratory tract here, and whatever we breathe in, it goes into what we call air sacs or alveoli, and by simple diffusion, oxygen gets into our blood system. So the issue comes up with silica is that you have your lungs, right? And as you go into this, there's, when you breathe in, this dust particle, or the silica, can attach inside to the lining of the villi. And this will cause the mucus increase, and it will cause blockages. Okay, so this is your mucus cell, the cilia, and you also can have dust that can accumulate. And eventually you can have something that occurs as a result of exposure to a dust particle such as silica, which is COPD, or you can actually have silicosis, which is inflammation, which occurs from the exposure to silica. Okay, so this is what we're going to try and prevent by monitoring the respirables in the air. And as the evidence that's recorded, and if you read through your rule, it's really interesting to see the case studies. There is case study after case study of individuals that have been diagnosed with COPD, with silicosis upon exposure. And they've actually isolated the variable that was silica. That's how the rule came into play. So as I said and mentioned, it's important that you do, as safety professionals, grab your rule, read through it, and you actually have case studies right in here that'll tell you, Joe experienced this, and it goes step by step how they went through this diagnosis and went through that. Other diseases that you can come with silicosis, it can be COPD, it can have lung cancer, and even kidney disease can occur from silicosis. So based on these findings and the evidence that you can find in the standard, there is all kinds of scientific research in this standard. The literature is in there. It's included in there, as well as what type of diseases you may see. Okay, so the final rule establishes a different level of permissible exposure level than we had before. Before we had 100 microns and 250 for construction. General industry was 100. Okay, and then we had 250 for construction. With this final rule, it dropped it. Okay, so now permissible exposure is 50 micrograms or microns per cubic meter. Okay, of respirable silica is allowed in the air in an 8-hour time weighted average, okay, for general industry. So how much is that? How much silica is that? That sounds like a number. How do I deal with it? How do as a safety professional do I comply with that number? How do I know? Right? And so that's very difficult with a new standard and regulation, because as I mentioned before, we kind of, we follow others' lead. And so this one is interesting and evolving because, well, who knows? Well, if they're not reading the regulation, you wouldn't know. Okay? And that's where it's important to understand, because in the regulation, it actually tells you exposure assessment. It talks about the controlling exposure and the respiratory protection, medical surveillance, hazard communication, and record keeping. It's all in there. And there's not a template out there yet. Okay. For other policies, we do have all these templates that we run to, right? Very rarely do you see a safety professional that can technical writing and knows how to technically write. Okay. So let's look at how much 50 microns is. Okay. So before we had 200 micrograms per cubic meter. Okay, and now our exposure would be 50 micrograms per cubic meter. So on your desk, just to give you a visual, you have a packet, a 1 gram packet of sweetener, right? Okay. Okay, so if you draw a circle on your piece of paper, there's a pen, if you have a pen, draw a circle. Okay, and we're going to just take the 1 gram, and we're going to put it right in the center of the circle, right? Yes, because it's 1 gram. We're going to have 1 gram in the center. You take the second piece of paper, and once you've drawn the circle, you fold it, 1/2, second half. Okay. So what are we going to do is we're going to divide the 1 gram, okay, in half. And we're just going to half it as best you can and separate it out of your circle. Okay? Right? So you're going to go in half. So we have 1/2 gram now, right? Okay, so 1/2 of 1 gram. All right, so now take that, divide it in half, and sift it off again. That's 2. Divide it in half, and again. That's 3. Divide it in half, and again, 4. Divide it in half, and again, 5. Divide it in half, again, 6. We'll keep going. Divide it in half, and again, 7. Divide it in half, again, 8. Keep going. Divide it in half, again, 9. Divide it in half, again, 10. Keep going. Divide it in half, again, 11. Divide it in half, again, 12. Divide it again, I have 13. Divide it in half, again, 14. That's it. That's the amount of silica that employees can be exposed to in an 8-hour shift. Right, right. So now you have a visual before you, right? So this is quite common in construction, right? We're going to look at the uses of construction when we use it in common industry and oil and gas industry. We use it in fracking. So I'm going to give you another mathematical. Okay. So in construction, okay. So we have a paper, and he actually has a paper. The size is 60 millimeters. Okay. And so, which is 2.36 inches thick. Okay, and weighs 65,770 grams per cubic foot, or 3 grams per cubic inch. Okay, so paper material weighs 65,770 grams per cubic foot, because we're dealing with metric system. We have to convert, right? And then you divide it by 1,728 inches cubic feet. So you have 38 grams per cubic inch. All right. So now, same paper. He cuts a 4-inch long cross cut using 1/8 inch blade, which takes out 1.18 cubic inches of material. Okay, let's see how much exposure he has, because this is quite common, right? So the material removed by the cutting was 2.36 in depth of cut times 4 inch of length times 0.125 inch thick blade. 1.1 inch cubic inches removed times 38 grams cubic inches, you have 45 grams removed. Okay? You still with me? All right. So you're going to convert the grams to micrograms now. Okay? So 1 million micrograms per gram times 45 grams. So that gives you 45 million micrograms removed. when you're talking about this type of brick, 60 millimeter, it is 20% silica. So if you take 20% of the 45 million, it's 9 million micrograms silica removed per cut. That's how much of exposure you have. Okay, so this is an important regulation. Okay, I know that's something that we, silica is there, we've dealt with it all, but I mean, basically it's very close to, it's not there, but I mean, you can't even see it, right? So let's look at some common uses where this can affect. All right, so oil and gas, hydraulic fracking. You use a lot of sand in fracking, okay? And we're talking thousands of pounds of sand. And so just let's give you an idea. And it keeps increasing, especially in the oil and gas industry in Permian Basin. We have a lot of fracking. And this is the number 2013. They had 30 million tons used in 2013 in fracking. That's how much sand you use in oil and gas. All right. And just again, on 2000, more recent, 2018, average tons that were used in 2018 first quarter were close to 90,000 tons of sand. And so where do we get all this sand from? Okay, well there's different areas throughout the United States that you can actually go and purchase sand, okay, for oil and gas or for construction or whatever you need it for, whatever use. All right, sand blasting, okay, uses sand. Okay, silica uses silica. Road construction, concrete construction uses silica. So silica is also used in manufacturing of kitchen countertops. Also, its silica content of the countertops is about 85% content of silica in those countertops. Glass and ceramics, you use it in metal foundries when they're making metal. You use that. And also the castings, your mold casting. Silica sand is also used to purify waters. And then also for fillers, plastic, rubber, even cosmetics and soaps, they use silica. So it does impact many, many different industries. So over 30 major industries and operations have a possible exposure to crystalline silica. So this includes, as mentioned, even dental offices, dental laboratories use silica as well. So it has a big impact across the board. So it's something that as safety professionals we have to be knowledgeable and be familiar with our regulation. Okay, and just an idea of construction, okay, because they do deal a lot with construction. And so just a construction worker and the possible exposure of silica for construction worker. And this is dealing with micrograms per meter, cubic meter. So percentage of workers exposed to silica by exposure level construction versus all industry. The construction is more, as far as in the red, is the one that you see more exposure in because of, again, the element of countertops, kitchens, drilling, grinding. Anytime you take quartz and you drill and you grind, it becomes respirable, as mentioned with the paver. That's why I give the example of the paver, because that's quite common to do. So as safety professionals, some compliance issues that we need to overcome. Okay. So some methods are mentioned on how to control the spiral. And depending on the industry that you're dealing with, there is some mention in the regulation, and I'll go over those. One that I'm more familiar with and that I've seen evolve is the oil and gas, and that is an example that I will give you that I see evolving at this time. So it's 50 micrograms or microns per cubic meter. And of course, when we're dealing with compliance issues as safety professionals, we have to be familiar that the first thing we want to try and do is eliminate. If we can't eliminate, we have to substitute and then set up engineering controls. Okay, we got to set up those engineering controls, then the standards and procedures, and then the PPE. Definitely want to do that. So the rule requires employers to implement engineering controls first. We want to do that first. Okay? And in situations where engineering controls, where practices don't work, the last resort would be the PPE. That would be the last resort. So in the standard, it's actually interesting to read. It says, OSHA standards may be technology forcing. Right? It says technology forcing. So where the, it hasn't evolved there. It's still going. They haven't basically set up instrumentation, equipment to be able to keep the exposure from happening. Right? So that's what's been really interesting to watch. And it basically, this is verbatim from the regulation. OSHA is not bound by the technological status quo. That's how it's stated. Okay, so with that, I've witnessed this, the delivery systems. And oil and gas is an example that I'm going to give you because we use tons and tons and tons of it a year. Okay, and kind of gave you the numbers to deal with. So one of the examples, and I have to show you, maybe. I tried to play you the video as far as the delivery systems and how the industry has evolved to set up delivery systems that limit the exposure of the employee, because that would be your engineering controls, right? So one would be how it's transported, okay, the transport system. And so what they have is before, let's see if I can show you this. Before we used to use big, large sand trucks, right? And they haul the sand back and forth. And so with this new regulation, that's not possible to do the sand trucks. So maybe I can show you a picture. And so what they use now is these more compact versions called, an example would be something called arrows up. Okay? And that's how it's transported from one point to another in a box style. Okay? That would be transport. Another way of the delivery system that they have, not only just the box, they have a system that they elevate the sand. Okay? And it's in this CG Logistics actually has designed a type of elevating the sand to the silos. And there's actually one in particular that I was going to try and show you. I apologize, but there is one of my clients that I wanted to share this story with you because, a lot of these technological forcing regulations have actually pushed people to actually design new patents. And so this gentleman, he doesn't work for it, but he actually designed his own patent. He drove a sand truck, and when he heard about this, the regulation starting, he was on a major location fracking, and the engineer was talking to him about this new regulation. Says, hey, you know what, you're going to have to get rid of your sand truck because, we're going to have to look at a different method of delivering so we can limit the amount of silica. Well, what this gentleman does, he designs it on a napkin and talks to the engineer. Now, this is a simple truck driver, okay? Designs it on a napkin and hands it to the engineer and says, do you think this would work? And then the engineer said, yeah, it looks like it would. So he crosses the border, goes to Mexico, has it built, comes back, and guess what? They loved it. It's a conveyor belt system, and it conveys all the sand up to the silos. And the silo of the truck now, that used to be a sand truck, now flips on the side and becomes 3 silos. Okay. So it's interesting how regulation has pushed technology and actually design, and from the common man. And so it's interesting to try and evolve safety programs around this as a safety professional. And it's a challenge. It's a challenge because we have to limit the exposure. I do apologize that I can't play the videos for you, I do. But when we're doing these types of designs and conveyor belt systems, we're doing transport, we have to think about the location and the layout of where that frac is occurring, and can we actually accomplish it. And so when we're dealing with silica, as you just witnessed, it's a very minute amount of silica that an employee can be exposed to. Because not only do we have to think about our employees, we have to think about the welder, we have to think about other people on location, because with sim-ops, with simultaneous operations occurring, other people could be exposed. And the variations in the process. We could easily have the sandblaster come in and changes, things have just changed, so the process may change. So we have to make sure that we set up engineering controls around all of this. And this is a big issue in oil and gas. How are we going to comply? How are we going to comply with layout, delivery system, the variation? So we do see the new designs, the new innovations coming out. Okay? So if you work in other industries, some of the compliance methods that you'll have is similar to with asbestos. Okay? So you use water for cutting, okay? Contain the work area, and then filters, HIPAA filters, as well as provide respirators, as that's your last resort as safety professionals. So you definitely need to get a hold of regulation. If you work in an industry that possibly can have exposure, you definitely want to read into more compliance. And of course, signage, postage, make sure you have people understand that there's silica in the area. In conclusion, silica is just simply silicon dioxide, most abundant element on the planet, silicon and oxygen. Okay? Industries which are silica or have the silica work in, oil and gas, manufacturing, construction, even your own body has silica in it, right? That's weird. OSHA final rule on silica now has a permissible exposure of 50 micrograms per cubic meter of respirable crystalline silica. And the big thing is respirable, is the size. Is it respirable? Also, some challenges as a safety professional is the compliance. Okay, the technology is not there. How to set up the engineering controls. What are we going to do to protect our worker? And then as well as, is it economically feasible? It's another thing, so we have to think about that. So solutions would be just wetting, use water when cutting, contain the work area, filter the air, and provide respirators for last resort. Questions?